Welcome to session 3 of 5 on the technical webinar series. Today we're going to talk about mechanical systems. My name is Tom Zhang, Senior Engineer at Optimus Solutions, and I got my buddy over here,
Mike Lyons with the Eastern District for Industrial Kiln and Dryer.
And just to let you guys know, we got to do some housekeeping. We got to make sure for the attendees to have your webcams open. If you see my face and Mike's pretty face, and the feedback was that everyone liked his hat and all that kind of stuff. Yeah, it's mainly to make sure that if you see the dryer online, we got some stuff that we want to show, so that way everybody's interactive. Okay, so that's just some housekeeping stuff. Make sure you guys can see the webcams. If not, there's a question box in the GoToMeeting where you guys can ask some questions or any technical difficulties. We do have a crew working behind the scenes to help out with those concerns. Okay, without further ado, get started. Okay, so on the last webinar, actually we've done 2 of these already.
Yeah, they're going good.
This is session 3. We're talking about mechanical systems this time. We're going through a lot of different components, gears, bearings.
Yeah, we could take really a deeper dive into just about any one of these parts, and it goes by pretty quick. So if you guys run into something that we don't cover, all means reach out to us and we can help you out afterwards.
Right, and just like last time, this webinar series reflects the 3 regional trainings that we do. This is an online version of it, especially with the current situation that we have in the world. So we're going to jump right into it today. You got kilns, you got dryers, you got ball mills, you got a lot of rotating equipment. In order to rotate it, you start with the drive system. I know some of you guys have chain systems, some of you guys have trunnion driven. So I like to start with drives because I would say this is a little bit more involved a lot of times. So why? Why drive systems? What are the different types? Well, to start off with, you got to pick a material, right? And just the material itself, as you guys see, there's a lot of different types. You have through hardened, you have castables, you have case hardened. We even have some newer materials.
Now, would the size of the gear maybe determine the type of material?
Yes, absolutely. Or the overall tolerance. Right, so if you got a tighter tolerance or a tighter grade, then there may be a different material or maybe a different process for the materials to make sure that the quality is there. Just for everyone's information on this is what I'm showing you here is Austempered Ductile iron or ADI material. This has been a relatively new advancement, especially with gears, 20, 30 years. I think one of the groups that we work with, they've effectively perfected this material processing of it. And what I want to say here is that some of the service factors related to it compared to regular steel, it has a tendency to be better, as you can see on the pitting. And other than the pinion a little bit, you have another good service factor for the bending stress. Typically, pitting is what matters more, what occurs more often. So in terms of ADI, what's interesting is you have the potential to change the size, which you were alluding to, Mike, on does the material change the size? There's a few things that I've seen philosophically, because I know, especially nowadays, it's like, well, you're trying to make things thinner and thinner. How beefy is it, right?
You could definitely look at it as being not as strong of a gear because it is smaller in size, or the face width is not as,
or at least it's smaller of equivalence, right?
Sure.
So it's like, well, we're trying to be all so there's 2 philosophies that I can kind of go into here. You can say have a gear with this particular size and reduce it and have, say, an effective equivalency on the grades, on the hardness, on the strength, and say, hey, we can make it smaller and it has the same effect, right? So that's what a lot of people are always like, well, if you keep making it there. Well, my view is, why not keep it the same sometimes? If it's 16 and you keep it at 16 inch on the face width, it's effectively much stronger. So then the question is, do you want it really, really beefy, or you want it really, really lean, or somewhere in between?
Right.
So this, I think, is where IKD comes in, or Optimus comes in. We have that discussion point.
Sure.
Because if you go buy a truck, you can either buy the one that gets the job done, or you can get the one that you put everything you want in it. Right?
Well, you want to bring in the experts.
You want to bring in the experts. Right. Absolutely. So yeah, this one's a very interesting material, and ultimately it's a tempering process for the iron. Okay, and what it does is it creates additional what I call what I want to call it. It's almost like a micro fissure, micro cracks in it, where if you have two plates, right, like this, it'll move. Okay. If you have a plate here and a plate here and a plate around it, it's going to be harder to move. This is on the micro level with these types of materials, to where you form these little bubbles inside, or little fissures inside, where it all connects. That's where the strength comes from a lot of times on this. And then you have other heat treatment mechanisms to either have a more uniform shape on the outside, or whatever it may be. But that's kind of the idea behind the technology on this. We can go through more detail if you guys have questions on it.
Sure.
Okay, gear width. So a lot of the larger girth gears typically have high horsepower, or with helical. A lot of the strength of materials used in pads require large face width. So again, the idea here is, when it was, say, 50 years ago or 60 years ago, you didn't have a lot of the computational power to make it really lean in terms of the design standpoint. So you got to make it real beefy, really big to withstand. So again, it goes back to, you can make it real lean, real efficient now, or you can leave it at that and make it really beefy and go further with it. Ultimately, these types of things comes down to cost, comes down to personalities.
Would you get into more of the on the larger gears? Would you see that more into the cement industry, or paper mill, or larger units, so to speak?
Yeah, actually, so you brought up a good point about cement. In cement, the kiln is the bread and butter. Okay, if the kiln fails, you're talking millions of dollars a day that you're losing, right? So it's not a secondary piece of equipment. If it's down, you can't just turn something else on. It is the core. So naturally, that makes and cement tends to be relatively technical in terms of, okay, I want all these features. So when you're a little bit more conservative, because the risk is higher, and you like to go further on the technologies and the technical ideas behind it, you're going to want to over-design. So then in cement, you will have a lot of extras on top of it, because the cost or the risk is higher. Whereas some of the other industries, maybe you don't necessarily need that extra beefiness or that extra strength or all that, and you want to be as lean as possible to move ahead on it. Now that's kind of the other design philosophy. So then it comes down to cost.
Makes sense.
Right. You got lots of different types of gear mounting systems. Okay, so you have something on the left that we see is a leaf spring type of mechanism, or a lug and chair mounting system. Again, guys, we have a lot of material to cover. I mean, this is just gears. We got gears, pinions, trunnions, tires, et cetera, et cetera. The point I want to make here is leaf spring is for high temperature, and then lug and chair typically is for low temperature. I want to qualify that with high and low temperature. My rule of thumb is about 200 degrees F. Okay. So the leaf spring, say on a kiln, you're talking maybe 500, 600, 800 degrees F. Try not to get it above 700 degrees F, then you have issues with your shelf. But that spring allows for that change in thermal expansion. And then the lug is if you have that same issue on a kiln, then it will break.
Bad news. Bad news.
So flange and spring mount options, spring plates. So there's lots of different mounting systems out there. It ultimately comes down to your particular needs, your particular risk factors, and that's where we can help integrate these thoughts in. We don't just make a gear, put it in, and it fits. We want to make a gear, put it in, it fits, and it solves a problem or it's better, right? Whatever we define that as.
Well, on this particular one that we're showing here on the slide, that tends to be more of a newer technology where you're seeing the multi-pieces like that.
Yeah, the segmented gear. I would say one of the criticisms that segmented gears have had, say 20 or 30 years ago, is the precision, or how good of a quality control on, if I have 100 pieces of this, are they all exactly the same, or whatever we define it as exactly, right? Is it within 5 thousandths on everything? And nowadays, these things can scale up quite a bit. I don't know if you've seen any of the larger ones. I mean, maybe 20 feet or more.
That's the largest one I've seen.
Okay. This type of technique, in terms of the segmented pieces, you're looking, the bigger it is, the more cost effective actually, because you're just copy and pasting that segment. So if it's too small, then you may look at a more traditional one piece.
Or two piece.
Or two piece. Oh yeah, yes,
yeah.
Two piece. Okay. So we talked a little bit about the gear and the gear mounting. So now you got the pinions. Okay. So you got a reducer mounted type of a system or a pinion shaft mounted type of a system. Pinion shaft, I would say, is more common. You got the pinion with the two bearings next to it, and then you got a coupler, and then you got a reducer, and you got a reducer with a high-speed coupler, and then to the drive. That, I would say, is more common.
Would you say the one with the pinion and shaft and two bearings, is that more for a rigid mount?
Yes. Yes, it's a, you want to make sure everything is shimmed right, aligned right on that spot. You want to make sure your gear run out and every lubrication is good. These aren't the cheapest, especially gear mounted type of systems. Excuse me, compared to maybe a chain drive type of a system, a chain sprocket system. Gears, pinion gear type of systems last a lot longer than chain sprocket types. But also you don't have, because it's higher precision, you don't have as much play to, say, move the unit uphill, downhill, because you want to keep that gear in the gearbox. And so this is where later we'll talk a little bit about the thrust roller and making sure it's tight. If you got a chain system, chain systems are a little bit cheaper. It's sloppier in the sense it's chain, right?
Right.
You can move back and forth a little bit. The issue is then you may be replacing chain more, et cetera, et cetera.
You tend to see the chain set up in the industry where the dryers are maybe like a 10 to 15 year life expectancy.
Right, right. A little bit, maybe 4,000 hours a year versus 8,000 hours a year.
Something like that.
Something like that. Okay, so couplers. Okay, you got there's all sorts of different types of couplers. So low speed couplers are couplers from the gearbox down to the pinion. You got grid styles, gear coupling styles. I'll say fluid couplings. I tend to like the fluid couplings a little bit more, in the sense that when you turn the unit on, the fluid has to engage.
Correct.
When the fluid engages, it gives it a little bit of lag to where then as it turns, you don't just immediately go.
It's a softer start.
It's a soft start, yeah. It's like, in your router at home, the soft starts versus it goes immediately up.
Correct.
Because when it goes from 0 to 100, that does add a lot of torque in there, and if you don't have it aligned right, it's a lot less forgiving. Whereas in the fluid coupling system, it's a little bit more forgiving. Okay, and these typically you gotta get your motor hooked up to the gear reducer. These will be some of the high speed.
It's easier on the drive components.
Yes. Reducers, man, there's a lot. I mean, we can go on and on about all the different potential components on it. One of the things we've noticed on the newer reducers is size. They got smaller and smaller and smaller.
It goes back to what we were talking about with the gears.
Right.
The technology and the material have gotten better.
Right. I would say the main con of reducing on the size is you're inputting more work. Okay. And then heat transfer, if you put more work, you tend to create more heat. So therefore, the smaller it is, the less area that the heat can dissipate. So that's where on the smaller ones, you may, if it's cold outside, you may have to have a heater in there. And then the heat is not really an issue in terms of cooling the reducer because it's for weather. Or if you're in a hotter environment and it does get hot, the consequence of that is hot reducers, hot typically changes the oil viscosity. If it's like you got honey, you heat up the honey, or you heat up some thick lubricant, it becomes very watery. Okay, and lubrication, the higher the viscosity, the better the protection, because viscosity ultimately leaves a film, and the lower the viscosity, the thinner it is. The thinner the film, the less protection it has. So that's where controlling the temperature is important, because it'll A, help on the viscosity on the oil, and B, also any odd thermal expansions in the unit. So these are some of the hot stuff. Okay, and actually I think we talked a little bit about the excessive heat reduces oil life, film thickness, et cetera, et cetera. Okay, so this just gives you an example of the magnitude of the size difference. I mean, well, you got the 50s. That's what do you say? That's about a fourth,
at least,
of what it used to. And the weight difference is like a tenth. So it's pretty amazing how it's changed.
Oh, it's evolved.
It's evolved. But like I said, I know a lot of guys, they like to stick with the older stuff because maybe it's less moving parts or whatever it is.
Well, also, too, if you can keep what you have, you don't have the modifications that are going to be required to go to a smaller gearbox.
Right. Maybe have the same location where the pinion hooks up to where it's a drop-in type of a deal. But again, these are all things. It's not really just a catalog system, right? It's like, hey, I want this, install it.
Oh, it takes a little bit of engineering. You've got to get a lot of information put together before you can go size a gearbox.
And that's one of the differences that we do, is that we make sure that we ask the right questions. We try to help you solve the problem, right? Hey, this has been giving me trouble. Okay, cool. And we try to help integrate the right solution to help you guys out.
Yeah.
Oh, and this is some of the cool FinTech technology. Oh, what it is how to remove the heat. You'll see this, I think that was like an aluminum fin heat exchanger channel on the right here. You'll see that aluminum piece. The top are the fins. They dissipate the heat, or they actually absorb the heat. And the top on that is where the either a water or some kind of fluid that removes the heat. So you got those types of systems on it to keep it cool, or just put a fan on it.
Exactly. I was going to mention.
You do have seals that you need to make sure are well designed or well maintained.
Maintaining, for sure. A lot of times seals get overlooked.
Absolutely. I mean, how many times have you seen, even just on a bearing, you just see oil just coming out?
Exactly. I mean, it's everywhere coming out of the seals. And what you don't realize, again, a lot of times with a seal, as you know, with the heat expansion and contraction, if you've got materials coming out of the seal, and then you've got a dusty environment and it's clinging to the lubrication.
Right.
And this thing heats back up, it's swelling back up, and you're pulling that right back into the unit.
Well, also,
with your bearing or even with a reducer.
And most of the customer base that we work with, I mean, the material that they, like cement, I mean, that's not it's a pretty abrasive material.
Right.
So it's like, hey, you know what, let's just throw some sandpaper in there and see what happens, right? So ultimately you got aggregate or material in there that's foreign. These things rotate all the time, so now you're creating unnecessary grooves. You're creating wear and ultimately failure. So that's why it's good to do an oil analysis. It's good to do figure out what all the components are, either for debris or for wear. So some of these have bronze bearings or bronze sleeves in it that you want to know about.
And when you start thinking about the seals, you're thinking, oh, well, it's just an inexpensive item. It is, as far as replacement.
Right.
But what it's doing to the unit is catastrophic.
Right. The seal may be cheap, but the gear reducer may be less cheap. But really what matters is if the gear reducer gets the kiln or the dryer to stop, that's now cutting into your revenue stream.
Absolutely.
And that's just a simple thing we can all do. So auxiliary drives, so these are the, for failure, huh? So most of these will have our electric motors, and when the
or
power,
sometimes diesel.
Or well, in terms of your main motor.
Oh yes.
Your auxiliary drives, you're looking at diesel or some energy source outside of your grid, right? Because I know
Backup,
yeah. So I'll tell you, you got a kiln, you got a dryer, you got whatever is hot. You don't want it to just
stop.
Yeah, or stop. Because what do you think will happen if it just stops?
All kinds of bad things. All kinds of bad things.
So
it's very harsh on a shell just to stop, especially in the cement industry.
Yep. So let's say it's your power goes out, and it's always the worst time, right? It's in the middle of winter, or it's raining.
3 o'clock in the morning.
3 o'clock in the morning, and it'll take at least 30 minutes or so for someone to get there, or to even figure out what the problem is.
Right.
And your shell will droop. You will have your straight kiln shell in the span may become a divot now where it's not straight.
Or is what we like to call in the industry dog leg.
Or a dog leg, or a banana, depending on the region, or it could cause that type of a drooping on the tire, or a tire crank, or a tire dog leg. Now that causes other major problems. So we're going to go back to the auxiliary drive. What is it? Why is it important? Well, it allows you to just keep turning. Whether it's turning a little bit at a time, maybe once every 15 minutes or 30 minutes. But it's moving. Because you don't want that to droop, because an auxiliary drive compared to a shell section compared to your production loss is a big price difference.
Oh, yeah. Oh, yeah.
Right. Some of these you can engage and disengage. Some of these is already built into the system that you can engage, disengage. A lot of these details, if you guys are interested, we're more than happy to answer. But I just want to briefly show you that there is a difference. I mean, we can go all sorts of different directions on the auxiliary drives.
Again, with this segment, we have a lot of things we could cover in just 1 hour.
Right.
One topic.
Right. I mean, we try to actually go through the gear system and the pinion system and the drive system and the coupling system, and there is a lot of stuff.
Yeah.
Even though this, from one of the viewpoints, this is relatively straightforward. It's not that complicated. It kind of is once you go into the details. So thrust rollers. You wanna show the guys the thrust rollers a little bit?
Yeah, that'd be a good idea.
Yeah, because I think we got a little bit more light on it this time. We're gonna start moving over there. I'm gonna go ahead and close off this screen. So this again, guys, this is I'm gonna turn this part off so you guys can see a little bit better. Guys, let's see here. Should be able to zoom in a little bit.
Maybe able to.
A little tight. It's a little tight, but I think I got more light than last time. I think there's a little tiny thrust roller right there. Okay. I might even move this light a little bit closer. Oh, cool. So that's the thrust roller. So, Mike, what's the goal of the thrust roller?
Basically to take unit thrust, but not to carry the load.
Right. So, on a traditional thrust roller, and we'll go back to the slides later on it, the traditional thrust roller is there just as almost like a little gate. It's like, whoop, you hit it. It's like a tank hitting just a fence. It'll go through the fence, but if it's just enough that it's like, hey, it's a signal to me to go the other direction, that's the thrust.
Yeah, thrust bumper.
Right, bumper. Yeah. It is not designed. That thrust roller in this traditional style where it's just mounted on is not designed to hold 1 million to 2 million pounds. Okay? Now, there are designs out there that are designed to do that. That's what we call the hydraulic thrust.
Right.
And those are a little bit different animal, and they're a lot more complicated. They got hydraulics in place to ultimately what this thrust roller does is on this one, you want to neutralize all the rollers, make sure, and I think we talked a little bit about this in one of our other sessions, is you want to keep it the skew neutral. So this is like your car on the hill, you want to get it neutral, okay? So on this one, you want to be neutral first and then give it a slight uphill thrust. So then as it goes down, it bounces. And that's what we call the float. On a hydraulic thrust roller, and this has got a lot more complicated pieces on it, and cement is very common, everything has to be neutral, no uphill thrust, because that thrust roller is designed for it, and it moves a unit uphill and downhill.
And I can assure you, several people watching have experienced these things being snapped off.
Yeah, and typically it's an emergency job because it is much better to shut the unit off, put a thrust roller on, than to leave the unit running, and then you may have, let's see here.
Surely don't want the unit sliding.
That part sliding off. Yeah, because, I mean, if you got this, if you got a unit like this, we can put something here and lift this up.
Right.
It's free floating.
Right.
Nothing binding it down, nothing's locked, okay? So we just take this up, put it down, then, I mean.
We're back to good.
Back to good. All right, let's go back and chat a little bit about thrust rollers. Show my screen a little bit. Okay. Mike, why don't you turn on your webcam? Okay, so thrust rollers. So we talked a little bit about it. We showed you a little bit on the details of what that would look like. So I would say this is a traditional type of a thrust roller system. You got the mushroom thrust roller, or it's a mushroom because it looks like a mushroom. Got the bushing, and that's for that's effectively your bearing in a sense, and then your thrust washer, and then the housing. Very simple. It's there to only hold the thrust, not the whole unit.
Correct. Now, on this particular mushroom style, you normally see that on a tapered tire.
Yes, because there's a certain angle that you want to meet. So if you wear it and you want a new thrust roller, it's important to know what the angle is, or what the original angle is, or if it's changed, you've got to also figure that out. This one has a roller bearing inside of instead of a brass sleeve or a bushing on it. Again, these are just different styles in terms of the pure engineering on it. Some of them give a little bit more play, some of it doesn't give a little bit more play, some of them are more expensive, some of them are less expensive. Okay.
So just like your gear, it's going to be based on the design, the load.
Right. Thrust roller gap, you typically want some gap, okay? If you want no gap, your unit is not quote unquote floating.
You're trapping it.
You're trapping it. And some of the groups we worked with, they're like, hey man, this unit is doing great, and you're like, it's not moving, and both the thrust rollers are rotating.
It's one of the effects of trapping a unit.
Break the thrust roller.
There's that. Putting grooves in
it. So if you trap it and it can't move, you got grooves. You got thrust roller that could pop off. You got other wears on the support rollers, your pads, your retainers. So something so small as that can cause a lot of issues. And again, guys, this one could be catastrophic because we've seen it. Or it's another one of those things that over time you'll end up with problems. And that's the one that's harder, is that you won't know it's a problem until 6 months or a year from now.
Yeah.
Okay, so this one is pretty important.
Absolutely, absolutely.
Okay, so this one it's subtle. It's subtle until you see the issue. Okay, and so you want the thrust roller to be offset a little bit.
Sure.
Maybe a 1/4 inch, whatever it is. You want it a little bit, and you want it. So the center of the tire is the red line. Okay. Let's say the left side is the down turning side. You want that offset to the left.
Absolutely. Because what you got to remember is that thrust roller is just sitting in a housing. There is nothing holding it down other than gravity.
Right. So this will have the unit push the thrust roller downward. So what do you think will happen, Mike, if I move to the right side of that red line?
It's going to pick that thing up.
It's going to pick that thing up. So if you destroy the thrust roller because it was not on the right offset, just don't do that.
Yeah. No, it's practice to keep it over on the down turning side.
We have had a group that has happened, and the unit was 2 or 3 stories up, and it lifted it up, and a big old bang happened. And it could be as simple as it picked it up. And we actually went in and looked at the thrust roller, and all the bolts that kept it down, all of them were loose.
Wow.
So it picked it up and threw it back down, and the entire building shook.
Wow.
So it was a pretty major problem on it.
Yeah, important to check the center line, important to check the bolts.
Right. So overall, the thrust roller is a subtle thing. We talked a little bit about the. Hold on, let me see here.
How are we doing on time wise?
I think we're doing okay on time. I think I had some audio concerns. Just make sure. So again, guys, if you guys got some audio concerns, feel free to ask. We're on the phone line, so we're not connected to the internet. So the idea, if you guys do have some audio where you can't hear, sometimes if you call to try to listen, that could help. Otherwise, be cognizant of your internet connection. Sometimes that could cause some audio problems. That's why we switch over to phones only on here. Okay, so gear base and support roller assembly. Okay, so we talked on the gear. The reason we talked about gear is that's the main thing that moves it. Okay, and all the components to it, because you need to reduce all that. You need to go from 2,000 RPM on the motor down to say 1. Okay, so that's a lot of reduction. That's why you have all those drive components. We talked a little bit on the thrust roller, because if you're moving the unit and it hits the thrust roller, or you break it, or whatever it is, again, these are catastrophic failures. So now let's talk about the stuff that supports the unit. Okay. Oh, these are fun. Oh, okay. So both of these are dryers. Actually, the one up top, that dryer on a concrete pier, that's more common in, I would say, bigger units. And then the one at the bottom, that's on a, what do you call those? Metal frames, A-frames?
Yeah, just a standard metal frame.
Metal frame. those are better they're typically inexpensive. You can typically build it and then drop it in place. But a few things. It's not designed for higher loads because you got metal versus concrete. Concrete is very good compression types of material, so you can put a lot of weight on it and be fine. The other thing is it's hard to maintain, I think, on the metal pieces because you typically almost always have to have a ladder to get up there. Versus the concrete ones, it's a little bit more expensive, but when you're already in that phase, the groups almost always put a catwalk up there or some way to get up there easier. So that's just harder to get to. The other thing is concrete absorbs vibration better. When you have a metal like that, it tends to reverberate all the different vibrations. So these are just some of the piers because this stuff holds it.
Yeah, and a lot of times, even with concrete piers, you'll see items grouted in.
Yes. So you have the base, you have the grout under the base, and then you got the concrete pier under it, and then you have the foundation under that. Some of the foundations have gravel or something that's unstable. Or, I mean, I don't know if you've seen this a lot, but you see some lubrication that's leaked.
Oh, all the time. And also, to your point about the different styles, you'll see that with the heavier units, as you mentioned, going with the concrete piers.
Mm-hmm.
So
right.
It's a design.
Right. Well, I would say when we get a lot of vibration types of questions or concerns, one of the things I ask is it loose? And if you can't define it as loose, then we have a technology that we can look on the vibrations to see the loose.
Which is a pretty cool tool.
Yeah, that's a cool tool. If you guys have questions, you can ask me on that. It uses motion amplification. Ultimately, what it is you have a high-speed camera, and then we amplify the pixels on it, and it can show you where the vibration is. The key there is looseness. Hey, if you tighten this bolt down a little bit, it'll help.
We may all think about using or doing one of the webinars with showing that unit. It's a small segment.
We have a question.
Yes, ma'am.
Somebody asked, have you encountered concrete piers with newer additives, i.e. carbon nanotubes? If so, what's the performance of these compared to traditional concrete and rebar?
That is cool. That's a cool additive. That's more the concrete manufacturers. I do know they've looked at different types of additives, like carbon nanotubes is one. Another one is a self-healing type of a additive. And some of the more either eco-friendly types of additives. How that performs against traditional concrete and rebar, we actually don't know, but I do know that they are always looking for things like that. Typically what we do is it is very traditional on it, but I mean, that was a pretty cool question. I mean, I haven't heard anyone talk about carbon nanotubes on concrete piers. Now, you will need a lot of carbon nanotubes. So, because I know, I know you'll need a lot. Because I remember making some in the lab when I was in school. I tried to make some, and it's just like fluffy. It was like a fluffy thing on it. So you'll need a lot to add it. But the technique and the technology is good. Carbon nanotubes typically have very good tensile strength.
Okay.
So that's why, and concrete is typically, or cement itself is very good compression strength. That's why you have concrete and rebar. Concrete, compression strength, rebar, tensile strength. When you put those two together, it makes a very, very strong composite material. Carbon nanotubes are very strong in the tensile category, and when you add it in, it creates a better strength. That's my interpretation of that. But yeah, neat. Man, you guys should ask more questions like that are like that. I want more of those. So whoever. If you guys have more questions, just ask. That was neat.
You've definitely piqued his interest.
Oh, you piqued my interest. Now I gotta go look it up. Okay, so support bases. Okay, so when we install support bases, let me make sure we got the time. Okay. When we do support bases, if it's on a concrete pier, you typically want to grout it under it, okay? And when we say grout will have the epoxy mix on it, and the idea is it effectively glues the base to the concrete pier.
Right.
If you don't do that, ultimately, if it vibrates, and these will inevitably vibrate, it will loosen.
You'll definitely have a lot of issues.
Right. Right.
And over time, it's going to loosen. I mean,
over time, it will. And the thing is, if you have a properly installed base with the proper angle, with everything in place, it'll last quite a while.
It'll deteriorate over time.
It still will deteriorate over time, especially if you don't maintain it well and you got lubrication on it.
Well, that's what I was going to say, back to what you asked me earlier before we jumped on to the other topic, is lubrication. And a lot of times that is a huge problem. That's a big reason why you have a lot of failures with piers and
so on the piers, do you see like a big old like pool of lube from the bearings down?
Absolutely.
You look in, you're like, hey guys, I need you to get rid of this.
Yep.
I mean, there's gonna be water, there's gonna be rain that happens. You want to make sure it drains, but when you see the big old amount of just lube sitting there and it's just soaking in,
bad news.
Bad news. And it may not happen now, but it will happen later.
Eventually.
Okay, so we talked about the piers, we talked about the grout, the bases. Okay, now let's talk about the roller bearing types. Okay, so there's two common ones that we work with. The smaller units, you got a spherical roller bearing,
right?
Where inside you got ball bearings and it rotates, and you got sleeve bearings, and this is typically a brass sleeve that's about 30. It's in a 30-degree angle, and we'll go through some details on it. The spherical roller portion is here. I think you guys can see my mouse a little bit. So those are the different types of either you can have a fixed end or a floating end. It either can move or it can't move. And the spherical is to be able to,
you get a little bit of room, just a little bit of room for misalignment.
Right, just a little bit. And this is typically for smaller units. Smaller units, say 8 foot and down, rotary dryers, lightweight.
Right.
Lightweight, when we say lightweight, we're talking 250,000 to 500,000 pounds. When we say heavy, you're talking like 1 million, 2 million pounds. Okay, so just to clarify, it's not like a 5-pound thing.
Right.
Again, on the roller bearings, there's lots of different styles. Spherical roller is a very common one that we work with. You have lots of different styles, and it's dependent on the customer. It's dependent on the engineering. It's dependent on the risk factor. It's dependent on the preference. Or, hey, we've got this style. It's worked for us for 30 years. My view is if it's worked for you for 30 years, then okay, let's explore that. Let's at least consider it and not just disregard it, because experience. It's worked. I've had customers that are like, hey, we've done this and it's worked for 30 years. Our goal is to make sure that is true.
There's nothing wrong with going back with liking kind.
Right. It's just we want to make sure we consider all the avenues, and you have all the information and a good discussion back and forth. Once we do get an agreement on it, okay, now we move forward. We don't want to just put this in and say, okay, here you go, because when we do that, or if things like that happen, you may have a problem that may have been passed that we just want to make sure that we cleaned up.
Right.
Okay. So, again, lots of different bearing styles. A lot of the failures on bearings is heavy misalignment. You have a little bit of room to play, but it's really still not much. Okay, it's not much. The other failure is, I think we just talked about the thrust, excessive thrust. And this is due to skewing your bearings too much. Okay, if you put in a 1/2 inch say the downhill of a bearing and left it, that's a quite a bit of thrust. And if you don't know why and you do that and then you fail it, then okay, you destroyed it. And then you got contamination and incompatible lubrication.
Which goes back to what I was talking about earlier with with lubrication coming out of the seals.
Right.
With the heat and expansion.
Right. I mean, it's as simple as that, I would say. I mean, when you have your guys go and squirt the lubrication on, just make sure that if they do squirt lubrication or inject or pump lubrication in there, to make sure you know the right amount. Because if you just sit there and then a whole bunch of lubrication comes out,
it's not fill it up till you see it come out the seals.
Yeah, and I think we were talking to a lubrication group, and they said a lot of the failures was because of over lubrication.
You just reduce the bearing life.
Right. So
with contamination.
Because it's coming out. I mean, if it's coming out, then something will get in. So keep that in mind. If you got a guy walking around putting a whole bunch of lubrication on the rollers, just more is not necessarily better. The right amount. Okay, so what type of oil? I'm actually reading some of the questions, guys. I got another one here that says, what type of oil do you recommend for lubrication? So in terms of lubrication, shout out to the guy that asked it. I know you. I appreciate the question. It depends on the viscosity. It depends on if it's a kiln application, if it's a spherical roller application. Kilns, you're looking at, say, 400 centistoke viscosity range, depending on how hot it is, maybe on the discharge here, because it's hot. Again, lubrication is all about the viscosity. High viscosity, think of like, in terms of daily life, think of honey versus water. Honey is, quote, thicker. Water is thinner. If it's thicker, it creates a thicker film, and that film will protect the metal contact. It's cheaper to replace lubricant than to replace a bearing.
Right.
Okay. So when you do that, we do have different lubrications out there for kilns, and we will send you some of that information on what types. We do have different partnerships that we can get particular styles for you. But ultimate answer is it depends. And ultimate answer depends on the weight, the heat, the application.
You've got to look at the system setup.
You got to look at the system setup. Hey, but I appreciate it, buddy. Okay, so again, failure slopes to steep. Put in a 1-inch shim and it creates a step-like function like that.
A lot of times, shimming for contact is not the way to go.
Normally, it's not. So we talked a little bit about roller sleeves. Kilns, these are sleeve type bearings. These are what I would call kiln types. You're looking at, so on a dryer that is 8 foot, maybe the roller itself is 30 inches, maybe a foot. So
sometimes that,
the size. Kilns, you're talking like this one's maybe 4 feet.
Oh yeah, large.
Maybe
a lot of
5
weight.
feet.
A lot of weight.
I have seen one that's bigger than Mike. Mike's like 6 foot something, and I was like, man, you look like a tiny human. And can you imagine an actual small person walking next to it? I mean, I was like, wow, that's interesting.
They're huge.
So you don't have as much play actually, because you have such a massive amount size that, I mean, 500,000 pounds is sitting there, right? So your risk goes up, because not only is it harder to replace it, so those smaller rollers, you can call us. We have actually inventory of a lot of the smaller ones. We do have some of the bigger ones, but you got to make sure you got the right sizes. We got some that's sitting outside from I think we got some like old Alice Chalmer.
I think we do.
Yeah, bearings sitting outside. These don't grow on trees very often.
No. a lot of times plants will have a few extras that, that are older, just in case of emergency situations.
Right. Now, if you don't have a spare, you probably need to get a spare. Okay.
And you bring up a very good point. Every item that we've pretty much covered, other than your peers, you should consider a critical component and should have a backup for it.
Yes. Yes. Critical spares, I would say rollers, bearings, brush roller. Now having a tire, that's a tire and a gear of spares. Now that's getting expensive. But let's say someone has a gear failure, they don't have a spare. How long would it take to get a gear to them?
Depending on the size, you could be anywhere from, on your smaller ones, you can go from 8 to 10 weeks, maybe 12 to 14 weeks.
Mm-hmm.
And then some of your larger gears could take up to 26 to 30 weeks to build.
It don't grow on trees, huh?
No.
Actually, even if it does grow on trees, it'll still take a while. But overall, though, the way I've always looked at it is, if this fails and you're down X amount of days, that's X amount of revenue you're not making. And I think we had a discussion a few years ago. This one customer he didn't have a critical spare, and I think ultimately, if he did nothing and the unit failed, it would have cost him about $3 million.
Wow.
And if they got a gear as a spare and it does fail, then he effectively gains the $3 million back. It's your opportunity cost or opportunity loss.
Right.
Okay.
And we have come up with some creative ways to piece things together to keep them going.
Right. Okay. Hey, I'm actually looking at these questions a little bit more. Okay, so here's a question for you, Mike. I like this question. If you have 5 dryers and they're all the same trunnions and bearings, how many spares would you recommend?
I would say at least 1 for each unit.
Okay. Hopefully that answers your question. On dryers, you got 2 piers. You got 4 rollers on each dryer. Okay, so if you have 5 and you have 1 for each, it covers if that 1 fails. It also will cover if 1 has multiple failures. The good thing is, if you have 1 for each, and let's say throughout the year you have, let's say, 1 that hits, and then you got another one that hits. Typically, hopefully, they don't happen all at the same time. We did have a customer that had 3 units, and they did fail 3 thrust rollers all within a month.
Wow.
And that one was a pain for them in terms of getting a spare.
And as far as the spares go, I would have a complete assembly. That's your support roller shaft and your 2 bearings, and actually have it assembled and ready to go.
Yeah. So on top of that, having assembled bearings and everything done, but in terms of the trunnions and bearings, have a set, 1 trunnion, 2 bearings for each component or each dryer. Okay, so kiln bearings. Man, there's only so much time, man. It goes by quick.
I told you.
You'll see this orange here. That's the kiln sleeve, the bearing sleeve. You want to make sure that there's nothing there, because if you get a groove, and this is important to talk about, if you get contamination, there's grooves, you actually reduce the viscosity of that lubrication, because you actually, in a sense, puncture it. And we can go through, if you guys got more questions on that, we can talk about that later. So if you got it's like you put water on a penny, how it kind of bubbles up. If you put a slice in it, it divvies it and actually breaks that bubble. If you touch it, it breaks it. That's the idea here, is that you can actually screw with the lubrication because of the grooves in there. Okay. Yeah, and you got a lot of different arrangements. You got lots of different OEMs out there. This is what I call a thrust button arrangement. You have a thrust button at the end. This is where some of the guys will hammer it, but you can actually find it by just looking at the roller in terms of the thrust. There's lots of different styles. Different OEMs have different styles. FLS has a certain style. AC has a certain style.
We got another question. How much vibration can be considered normal? Is there any recommended equipment to measure vibration?
Normal is always an interesting word. The interesting thing about kilns is in kilns, the speed is low, okay? And what I mean by low is it's under 10 hertz. 10 hertz means 10 cycles per second, okay? A lot of the vibration out there that you'll see in terms of the limits are typically for high frequencies, typically 100, 10,000 hertz in that range or higher, okay? In terms of the kilns, I haven't seen really in the market overall a vibration standard. And that's what's interesting to me, because now what I've learned is that the best way I can compare is a vibration from a like-to-like system. So if you have two units, then you're lucky because I can do a cross comparison.
Right.
I think you just did one for, well, you just did a drive replacement for a ball mill group in Ohio, and I did a vibration analysis on it. And we have a service that can help with it. We did a cross comparison with one unit versus the other. We can't give you a defined number because everything has its own unique specs. So we did a comparison of itself, or even say one bearing to another. And the work that we did, the drive replacement and the base replacement, it was a quarter of what it used to be. And it compared to another unit was lower actually than a unit that hasn't failed. So to answer your question on what's considered normal, I don't think there's really a normal. I don't have enough data to call it normal yet, but I can refer it to itself. And okay.
Did you get another question?
Yeah, I'm getting a question. I think I'm getting close to the end here. Oh no, I'm not. Okay, so let's see here. So
again, guys, if you all have more questions that we can't cover right now, please by all means reach out to us. And
please by all means, because I think I've already went past some of my time limits on it. Okay, so let's talk about the tire a little bit. In terms of the tires, the key part I want to show you is there's different amounts and different component sizes. A one-piece tire is the I would say the highest strength because it's one piece. If you have segments like 4-piece or even 2-piece, typically we would recommend this for say a lighter duty unit and or because it's like a logistical issue, like the building you can't put it in. Okay. So typically best case is one piece, but you sometimes may be forced to do multi-pieces. I want to talk on the pads a little bit. You have multiple pad types, okay? One of the major pad types here is what I call a splined tire system. This is a wishbone. Polysius has a system. FLS has a system. These tangential suspension systems are there to prevent creep, okay? These are actually not the most common, but they're at least really cool to look at and really complicated.
Really expensive, I would.
And really expensive, and these are things that if they fail spectacularly. But in terms of these tires, it's a unique design. For the regular tires, have the regular pad systems, and try to keep it at one piece. And some of this is lubrication related things. Most of these units, you want to keep it at graphite blocks or graphite lubrication. When you have grease or oil, even though it might look shiny and nice, you will see pitting occur. I think one of the questions is how much pitting is bad. You'll actually see this peppering of pitting all the way across. I would consider that bad, especially if you went from graphite to this and the pitting goes up. Okay, because that is a major problem with a oil-based or grease-based lubrication, because when you have that in there and it compresses, you now have a mechanism for failure. Graphite, the base material mechanism with graphite is its sheets, and the sheets peel off. So the coefficient of friction on it is not as good as an oil-based, but it's enough that you're not damaging your tire and roller. The goal is just to keep something between a tire and roller, okay? So if you get something like this where It's got inconsistent lubrication. It's shiny on certain spots. Typically, that means you want to put a little bit of scuff on it. I think we have a product now that you may not need to. If you got questions on that, ask your key account specialist on it.
That's pretty neat, new graphite block.
Yeah, it's neat. I think they use it for railroads.
Okay.
Okay, so just final couple of slides. If you could check your creep, great. If you could check your temperatures, great. Do things that you normally do to keep a good to-do list. You want to check a lot of stuff, right?
Your to-do list is your preventative maintenance.
Yeah, your PM.
Your trending information. A lot of times when we show up, that's one of the first things we ask. We try to get, what's your preventative maintenance schedule?
Right.
We take a look at it. What kind of abnormal temperatures, things that you're seeing that we can kind of start with.
Right, absolutely. So overall, I noticed we had a lot of questions on here. I think the team that's working in the back side has been trying to answer a lot of it. Again, if you guys have deeper questions, feel free to contact us. Either go to www.industrialkiln.com, 877-316-6140, or email us at contact@industrialkiln.com and say this is webinar session 4, if you can say that, or 3, my bad. If you could say that and let us know, we'll be more than happy to answer your question. We'll have a whole plethora of technical guys that will answer these.
And also, too, for the locations that are still accepting visitors, we can always try to come out and help out that way as well, and even do a virtual through Zoom. A lot of people are doing that now, too.
Right.
So we can do that. We don't necessarily have to be on site.
Right. So overall,
it's flying by when you're having fun.
It is flying by when you have fun. I mean, I would love to answer more questions, but I've actually exceeded my time limit now. So again, guys, we'll be reaching out to you for all the questions that haven't gotten answered. And again, we appreciate the time that you guys put on. I mean, an hour breezes by here. Again, you guys are essential. I noticed some of you guys on the listing are providing the essential services for the general public. All the stuff that people are buying out at the supermarkets. I noticed some of those guys that supply those like wipes and paper towels, et cetera, are actually on this webinar. So we appreciate you guys
absolutely
doing the best you can to make sure that we are safe and sane, really, because we were all quarantined.
Oh my gosh, right.
Again, you guys are essential. We are too, and we're ready to help, and we're open.
We appreciate you guys.
And we appreciate guys. So
stay safe and peace.
Peace. Thank you. Bye.